Imagine losing a lifetime of memories to an accident or disease. Poof, gone forever. Our brains are fragile biological hardware with no backup. But what if I told you that right now, in labs around the world, researchers aren't just imagining a solution, they are building it? This isn't sci-fi anymore. Today, we are diving into the frontier of neurotech to answer, can we really back up human memories like a hard disk? Imagine living yesterday twice. This is memory science's new reality. The pattern forming between those neurons is called an engram. Think of it less like a photograph and more like a symphony being played across your entire brain. That's the key insight. This fragile, distributed harmony is why memory is so powerful, yet also shockingly vulnerable to fading or corruption over time. Now, here's the real problem with that biological writing: it is not a calm transcription. It is a frantic, emotional battle for survival in your own mind. Every memory is fundamentally unstable, it's refabricated, not just replayed. The very act of remembering is an act of editing, which means your past is far more subjective and fragile than you've been led to believe. And this instability isn't a bug, it's the brutal feature of a living system. Your brain is not a perfect recorder, but an aggressive editor that prioritizes survival over accuracy. So when you recall a moment, you are not retrieving a file. You are actively rewriting your history based on what feels most true or most useful right now. The original is already gone. Memories aren't locked in your head, they are a file we're learning to copy. Now, let's be clear about the breakthrough. The key insight is that a memory has a precise physical signature, a unique neural pathway that fires in a specific sequence. What this means is that researchers did not just trigger a generic feeling of fear, they located the exact biological file and forced the system to open it on command. So, imagine finding the exact book containing a single memory on your brain's vast shelf. The mid-teen did more than just point to the shelf. They learned to copy that book's text perfectly. They could then place that copy back on the shelf, making the mouse's brain accept a completely new and entirely fictional chapter as a real memory. This discovery is the equivalent of finding the source code for a program. It tells us memory isn't just a vague feeling, it is a structured, physical signal we can intercept and duplicate. This fundamentally rewrites the rules, transforming biology from a passive storage device into an active, programmable system that we can potentially edit. Beyond simple recall lies the unsettling science of rewriting your past. So if the BCI is the port, then what's the drive? Here we enter the world of neuromorphic computing. These are specialized processors designed to mimic the brain's own architecture. Their efficiency makes them uniquely suited for running complex neural simulations, effectively providing the storage and processing hardware for something as vast and dynamic as a human memory. But this raw data is meaningless noise without translation. The key insight is that advanced AI acts as a universal decoder. It interprets that unique symphony of neural firing, converting it into a structured digital language. What this means is that without this AI bridge, the signal remains locked away, utterly unreadable and impossible to store. Think of your most cherished memory. What you are really trying to save is its meaning, the feeling, not just the chemistry. The profound challenge is that your brain's language is unlike anyone else's. The breakthrough isn't just in reading it, but in teaching an AI to understand the deeply personal context of your mind, distinguishing profound experience from background noise. Your memory is not a recording. It is a hackable, rewritable document. Think of your memories as a private diary you keep locked away. Now imagine a device that can, without ever opening the lock, translate the scribbles on the page into a clear movie for anyone to watch. That's what this technology is achieving. It's moving from reading simple words to projecting your most complex inner narratives. But forget that diary analogy. It is not publishing your private thoughts, it is translating the ink itself. This isn't a copy of your memory, this is intercepting the raw neural code for sensory experience. The pattern clearly indicates we aren't backing up the story, but are now scraping the hardware that renders reality, fundamentally rejecting the premise of a locked mind. So here is the stunning truth. Kernel has gone beyond passive scanning. Their systems are now designed to interface with neural data streams in real time. What this means is direct read access to the biological hardware of perception. This is no longer an observation, it is an active, ongoing extraction. The dream of backing up memories is becoming science, not science fiction. Now, the stark reality hits. The very systems designed to preserve your most personal experiences could become vectors for their destruction. Imagine a threat actor not just encrypting your data, but corrupting your very sense of self, demanding payment to restore your authentic past. This is an entirely new frontier of psychological and digital crime. But the ultimate breach isn't theft, it's ownership. We are discussing a world where a powerful entity does not just access your past, but rewrites it. They could inject narratives, erase traumas you need, or fabricate loyalty. This isn't about corrupting data, it is about seizing the foundational code of who you are and editing it to serve their purpose. And this fight would rage in the courts for generations. If a corporation archives your consciousness, does that data become their intellectual property? Could your family inherit a digital ghost, or would it be locked behind a corporate paywall? The legal system isn't ready. We are not just debating privacy, we are defining the very legal status of a human soul. Memory backup isn't a myth, it is an emerging engineering problem centered on decoding our brain's unique neural language. We already have the basic read-write tools with BCIs and AI, but the real challenge is ethics, security, and defining what a memory even is. This technology will likely arrive not as a sudden consumer product, but first as a medical treatment for Alzheimer's or PTSD, rewriting how we heal. Think about one memory you'd save first if you could. Let me know in the comments what it is and why.